Welcome back here, 8th grade BDS students here in Algebra 1. We're going to start into Chapter 8 now. New chapter means we have a fresh start for those of you that have been slacking, thinking we're getting towards the end of the year and you can kind of take a break. Sorry, that's kind of not how things work, unfortunately, in the world of academics. When you get to the end of the year, that means you have to work that much harder to get to the end of the year because the stuff is the most difficult now. So section 1 here is going to be a little bit of a review. This one should not be hard. The rest of the sections are all going to be brand new material that you're going to have to work at. This one should be a review from, I know, last year and probably even in 6th grade too. So we're talking about, sorry about that. The microphone just came off of my shirt. Reclip that on. All right. Try this again. So we're talking about factors and GCF, and we're going to be factoring polynomials eventually. But to review, we're just going to start with factoring normal monomials like you have in the past. So GCF, remember, stands for the greatest common factor. So whenever we're given two monomials, two polynomials, whatever it is, if we're looking for the greatest common factor, we're looking for the biggest thing that the biggest factor from both of those two monomials, okay? If we remember, we can find the GCF through prime factorization. Okay? The first thing we want to do is find the prime factorization for each monomial. And if we don't remember how to do that, we'll see in just an example here in just a second of how to do that. So first you find the prime factorization, then multiply the common prime factors together. Pick out the ones that they share, multiply them together. The result is our GCF. Okay, so let's take a look at this first example. This is a very, very simple one, the GCF of 30 and 24. Now, some of you are going to look at that and know right away that the GCF is 6. But we're not always going to have a nice, easy setup like this. So let's go through the process. First, we do the prime factorization. What two things multiply to give me 30? We know that 6 and 5 do. We know that 5 is prime. 6 can simplify to 2 and 3. Those are both prime. Now we do 24. We can do 6 and 4. 4 becomes 2 and 2. 6 becomes 2 and 3. Now we have to circle the things that they have in common. So they share a 2 and they share a 3. All right? Then we said the next step was to multiply the things they share. 2 times 3 gives me 6. So the GCF of 30 and 24 is 6. Okay? Then we'll take it up just a little bit, and you could do the same thing with 3 different monomials. 54, 36, and 45. Just because you have more numbers doesn't mean you change anything. We still start by finding the prime factorization. Okay, so 54 we can say is 9 times 6. 9 can be 3 and 3. 6 can be 2 and 3. 36 we can say 6 times 6. 6 becomes 2 and 3. And then 45, what two numbers multiply to 45? 2 of them, you can pick any two. We'll say 9 and 5. 9 becomes 3 and 3, and 5 is prime. Now we have to pick out everything that they share in common. They all have a 3, and they actually all have a second 3. So we can put a box around that 3. Now we have to see if there's anything else. There's a 3 for the 54, but nothing else has a 3 left. There's a 2 in the 54, a 2 in the 36, but there's no 2 in the 45. So the only thing they have are 3 times 3, which gives me a GCF of 9. Okay? So far, so good, I hope. So after this saves, there we are. Last example of this. I said this is going to be a quick one. This is just a review section to remind us what a GCF was. We have this monomial with numbers. So we have 36x squared y and 54xy cubed z. Okay? But remember, the first thing we need to do is split this into 36 and x squared y. Then we can split 36 into 6, 6, 2, 3, 2, and 3. Split this side into 54 xy cubed z. 54, we said it can be 9 and 6. 9 is 3 and 3. 6 is 2 and 3. Okay, now some of you that remember this might be wondering, why did I not split up all the variables? And I'm going to show you in just a second that there's a much quicker, easier way to do it than have to split them all up. Okay, so let's start with the numbers. What's the GCF of the numerical part? Well, we have a 3 that they share. We have a second 3 that they share. And we have a 2 that they share. So the number is 2 times 3 times 3. When we multiply all those together, 2 times 3 is 6. 6 times 3 is 9. So the GCF, 6 times 3 is 18. Okay, so the first part of the GCF is 18. Now, when I look at the numbers, it's very, very easy to pick out what they have in common. This, the 36, has 2 x's because of the exponent. 2 x's. 54 only has 1 x. Okay, if there's no number there, remember it's only 1. So how many can they share? The most that they can share, if there's 2 x's over here and 1 x over here, is 1x. So I know that 18x is part of it. Then I can look at my y's. Here I have 1 y. Here I have 3 y's. So how many can they share? They can share 1. Okay. Now the 54 has a z with it, but there's 1 z there. There's no z's over with the 36, so they don't share any of those. Remember, when we're looking for the GCF, we're always looking for what they share, which means that most that they share is 18xy. Okay? Now we're going to be doing a lot of this, so I hope that we understand this concept of finding the greatest common factor amongst monomials with these variables. Okay? The numbers you find just like you always have. Some of you will just know it right off the bat. Some of you are going to have to do the prime factorization to figure it out. But the more you practice it, the easier it's going to be. Okay? The variables, you just take whatever the lowest exponent is. So when we have the x squared and the x, you know that you take the x. When you have y cubed and y, you're going to take the y. If we had had an x squared and an x to the 4th, you're going to take x squared out because it's the smallest exponent. All right? So there's a quick, easy review section. Make sure we get the homework done. And we'll see you back here with section 2, which is going to be starting into factoring using the reverse of the distributive property. So good luck, and I'll see you in class. Bye.